Kepler's laws of planetary motion. Important terms about ellipse. This is an ellipse, and here you have a major axis and another minor axis. Half the length of the major axis is called semi-major axis equals A. Half the length of the minor axis is called semi-minor axis equals B. The axis cut at a point, it's called center. On the left hand side we have first focus, on the right hand side we have the second focus. We consider a point here, the length of the line joining focus 1 and the given point equals R1, and the length of the line joining the given point and the focus 2 equals R2. By theorem, R1 plus R2 equals 2 times A. Kepler's laws are stated as follows. At the first focus we have Sun, the second focus is empty. On the ellipse we have the planet, it goes around the Sun in an elliptical orbit. The farthest point of the planet from the Sun is called aphelion position, whereas the position of the planet very closest to the Sun is called perihelion position. At the aphelion position, the planet has the slowest speed. At the perihelion position, the planet has the highest speed. Let us learn the first law. Law of orbits. Each planet moves around the Sun in an elliptical orbit with the Sun at one of the foci. Each planet moves around the Sun in an elliptical orbit with the Sun at one of the foci. Let us see an animation. The planet at the aphelion position goes slower. At the perihelion position it goes faster. This is a major axis. It's a center, and the brown color length is called the semi-major axis A. The blue color line is R1, green color line is R2. By theorem, R1 plus R2 equals 2A. Let us learn the second law, law of area. Let us see an animation. This is the first planet, goes around the Sun in an elliptical orbit. At a given time T1, it covers an area A1. At the same time T2 equals T1, it covers another area A2 which is equal to A1. T1 equals T2 and A1 equals A2. As the planet goes slower, it covers less arc length at the aphelion position where it has a largest radius vector. Near the perihelion position, it goes faster and covers larger arc length, and it has the lowest radius vector. Let us learn the law. The radial vector, line joining the Sun and a planet, sweeps equal areas in equal intervals of time. It's a third law. Let us see another animation. This is the first planet, goes around the Sun in the blue orbit, where it has its semi-major axis equals A. It covers one revolution, its time period is P, so P square proportional to A cube. The second planet, the brown orbit, it has a period of revolution of P, and its semi-major axis is A. They are in brown color, so P square proportional to A cube, which is a constant. Law of period. The square of the time period of the revolution of a planet is directly proportional to cube of the semi-major axis of the ellipse. T square proportional to A cube. T square upon A cube equals a constant. Thank you.